18 h pile. Voilà, c'est important d'être à l'heure. C'est l'heure du Grand Témoin. Et ce n'est pas moi qui vais vous présenter le Grand Témoin de cette année. Je vais d'abord laisser les étudiantes et étudiants descendre avant de faire monter ici le lauréat du concours d'éloquence du Forum EPFL 2023. Il est étudiant en master en génie mécanique ici à l'EPFL. Et merci donc de faire un accueil chaleureux à Côme-Gaillard.
Chers étudiants, chaque année, l'EPFL, jouissant de la renommée qu'on lui connaît, permet à ses étudiants de suivre de nombreuses conférences données par d'éminentes personnalités. Aujourd'hui, et dans le cadre de votre cours de SHS sur les enjeux mondiaux, vous avez la chance d'écouter la secrétaire générale de l'Organisation mondiale de météorologie, l'OMM. Quand on me parle météo, je pense directement aux 5 minutes diffusées avant le JT de 19h30, ou de 20h pour nos amis français, et puis à une application plus ou moins précise, me permettant de savoir comment je vais pouvoir m'habiller demain, ou si je vais pouvoir aller skier ce week-end. Mais la météo, ou le mot météo, venant du grec ancien météoros, signifie ce qu'il y a au-dessus. Et donc, par extension, la météorologie devient la connaissance, le savoir, l'étude de ce qu'il y a au-dessus. Presque mystique. Cette brève excursion linguistique permet de redonner son importance première à la météorologie. Elle est la science des éléments, la science de ce qui nous entoure, la science de ce qui nous influence, nous et l'ensemble du vivant. Ainsi, quel que soit l'enjeu que vous avez choisi pour votre cours, la météo y joue forcément un rôle, reste à savoir lequel. Cette question centrale, qui a sûrement dû vous tarauder pendant toutes ces vacances, au même titre que vos résultats académiques, j'en suis sûr, mérite bien plus qu'une maigre analyse étymologique. Je vais donc devoir céder ma place à celle qui rayonne dans ce domaine, Madame Celeste Saulo. Enseignante et chercheuse en météorologie, notre invitée devient en 2014 la directrice du service météorologique national de l'Argentine et représente son pays à l'OMM. Elle rentre l'année suivante au conseil exécutif de cette organisation prestigieuse. Parallèlement, et depuis 2011, elle travaille au comité directeur du programme mondial de recherche sur la prévision du temps en tant qu'experte. Elle devient par la suite vice-présidente de l'OMM, avant d'être enfin la première femme élue secrétaire générale de l'OMM ce 1er janvier 2024. Je vous demande donc d'accueillir celle qui, jusque dans son prénom, était destinée à l'étude des voûtes célestes, Madame Celeste Saulo.
Okay. Oh, well, so nice to be here. Thank you so much for inviting me. It's a great honor, a great pleasure to be here with you today. I love being here. Sorry for my voice. I hope that my voice accompanies me through this talk. As you know, I've been a professor at the University of Buenos Aires, so I love teaching. I love being with students. I love your ideas. I love the way you think, the way you criticize, and the ways you make things happen. So I hope that with this talk, we can think together about a better world. So the title, Climate Changes. Weather speaks, and the question is, society reacts. I hope we can come up together to some answers to these questions. So this is the content of the talk. I'm planning to speak about our planet, how our planet is reacting to human activity, some indicators of the human activity in terms of greenhouse gases, and then something that is very keen to this course that you are taking. At the intersection of climate physics, climate chemistry, and society is where we feel the impacts. The impacts of what we do are there at that intersection. Then what about the future? And finally, adaptation, mitigation, and more. So just to be all of us on the same page, I'm sure that you know about this, but you know that because of, this is a physical basis of global warming. You have the energy that comes from the sun. It goes straight to our planet, to the Earth. Most of the energy is sent back to the atmosphere, and then some goes back to the space, but some of the energy stays in the atmosphere. That's because of the gases that are able to absorb energy. The main gases are water vapor, which is a natural gas, and then we have CO2, methane, and nitrous oxide. The problem here is that we have three main culprits that are mainly put in the atmosphere by us, by our activity, that it's not about their presence, because in a certain proportion they are okay, but it's about the balance. The question here is how much CO2, how much methane we put into the atmosphere, and how much we are able to remove. So you have CO2 emissions because of industry, because of deforestation, but you have CO2 uptake, things that can take CO2 from the atmosphere. For example, the forests, for example, the oceans. But it's about the budget. And the problem is that the budget is changing and the amount of CO2 is increasing. And because of this, we have a change in the radiation balance. And because of this, we have an increase in temperature because we are absorbing more radiation and we are heating and overheating the atmosphere and the whole system. This was a process that was known a long time ago, more than, I would say, 60 years. But we were not caring about that until science brought this problem into the scenario and said, okay, we have to do something. And we started to discuss this issue. I would say that Paris Agreement in 2015 was crucial to make some actions, concrete actions. And in the article number 4, this convention of this Paris Agreement mentions two emissions so as to achieve a balance between anthropogenic emissions by sources and removals by sinks of greenhouse gases in the second half of this century. We have to do something because otherwise we will continue increasing the amount of gases in the atmosphere. And that is not good for the health of our planet. Then, to translate these emissions into something that is more tangible, the Paris Agreement stated an overall ambition to limit warming well below 2 degrees, and try to put the best of our efforts to limit the temperature increase to 1.5 degrees above the pre-industrial levels. That was the target. That is our target. That is what we are working for. So I will share with you how the planet looks like now in terms of temperature and other indicators. This, of course, the credit to the IPCC, the Intergovernmental Panel on Climate Change, where we get the science to make these decisions. First, temperature. These are the global temperature anomalies. you know what anomalies are. You have a reference period, in this case, the pre-industrial times, 1850 to 1900. We have an average. That's why we have a zero over there. That is a reference period. And the anomalies are showing that since the 60s or the 80s, the anomaly is rising. And in 2023, we reached 1.45 degrees above this level. Remember about the Paris Agreement. And it was a record year, and as it says there, record heat has huge socioeconomic impacts. We will discuss that. And the other thing I want to highlight here, I don't know it, no, is that the last 9 years were the warmest on records. This is not a chance. So the trend is very clear. Let's see another variable, not just temperature. What is happening with the oceans? You can see here the global ocean heat content anomaly again. When you look at the anomaly, you look at zero. You have a reference period. Each curve shows a different layer within the ocean. You can go deep and deep into the ocean. Regardless of what layer you are looking at, the trend is really very clear. The trend is that the ocean is heating, clearly. And this will continue because this system has a strong inertia compared with the atmosphere. The atmosphere will also continue heating. But this process is irreversible on centennial to millennial timescales. Let's see another variable. Let's see mean global sea level. This is not an anomaly. This is the actual level of the sea. And you can see from 1993 up to now, it is rising very clearly. And the highest level was reached in 2023. And if you compare different decades, and you go for 1993, 2002, you can see the trend. The first decade that you have here, the growth rate was 2.14 millimeters per year. But now, during the last decade, the rate was 0.472 millimeters per year. This is accelerating. These are the concrete data. And you can see something different. You can see sea ice. You can see in the upper panel the status of sea ice extent in the northern pole. In the other panel, you can see what is happening in the south pole. And the curve looks like that because you are looking at the annual cycle. And the annual cycle is different in the northern hemisphere and in the southern hemisphere. But the interesting thing here is the ice sheet is diminishing and diminishing and diminishing. And that is because of melting. How can you tell that? Each line corresponds to a different year. Each blue line. The black line corresponds to the average. And the red line corresponds to 2023. Again, the lowest values in terms of sea ice extents are in 2023, both in the North Pole and in the Southern Pole. So these are the facts. This is what our planet is telling us. Let's see some indicators of our human activity. What are we doing in terms of greenhouse gases. And just to have a brief discussion, because sometimes these are topics that are being continuously argued. Let's see CO2 concentration in historical perspective. And if you go to the last point of this, from 1800, and that's just this end of the figure. Just for you to realize that over the last 800,000 years, we had CO2 values below pre-industrial area. Yes? That is shown by, I will move to here. I will stand just where I want you to look at. Here. 800,000 years ago, CO2 was below pre-industrial times. And as I move here, and I come to our few centuries, you can see a huge increase in CO2. Never in our history as a planet we had such an increase of CO2, such in a sudden. And if I move towards here, you will see what we call the scenarios, what could happen if we continue in the same direction. But going back to here, let's see, over 2020, where we are now, we are close to current levels of CO2, similar to a climate that happened 2 to 3 millions, 4 million years ago, with 2 or 3 degrees above what we observe now, and with sea levels 10 to 20 meters, 10 to 20 meters higher than today. And at the beginning, I spoke with you about budgets. It's not only about what we put, it's also about what we remove. This is an example of the CO2 annual budget. And you can see in oranges, you see the anthropogenic sources. We are putting lots of CO2, and the removals, both over land and over the oceans, are only about 50%. As a result, the atmospheric CO2 is growing. That's something we know. Methane, same case. If you look into the oranges, these are anthropogenic sources of methane. If you go into the greens, these are natural sources of methane. But if you combine all the sources and you remove the sinks, you will still have in red a change in atmospheric abundance of methane. And if we go to nitrous oxide, accounts for only 7% of the greenhouse gases, but still the anthropogenic source of nitrous oxide is huge. There are natural sources also, and the sinks are below that values, and that's why we have, again, an abundance of this gas in the atmosphere. So, we spoke about how the climate looks like. We spoke about how we are doing in terms of greenhouse gases emissions. Let's see something about the impacts. What is happening between the climate physics, the climate chemistry, and the socioeconomic impacts. And I would like to illustrate these impacts using what happened last year, 2023. This comes from a report that is generated by the World Meteorological Organization, WMO, as you say. And we had a year with lots of extreme events in terms of heat, affected many parts of the world. We had, of course, wildfires in Hawaii, Canada, Europe, with lots of lives and properties. And we had floodings, particularly very severe in the Mediterranean, associated with the Mediterranean cyclone Daniel, that affected Greece, Bulgaria, Turkey, and Libya. But Libya is more vulnerable, so there were many deaths because of this situation. So it comes here now, the other part of the story has to do with vulnerability. You have a risk, you have a hazard, but then you have vulnerability, and it's not the same everywhere around the world. In terms of fire, just look at that image that they placed over there. It has to do with the annual area burned in Canada since 1983 to 2023. So wildfires or fires in Canada are common, I would say. But look what happened in 2023. It was massive, it was abrupt, it was extreme. So we have more extreme events, and they are really very damaging. Extreme heat is also an issue to consider, because heat wave mortality could be 30 times larger than what we are accounting for. And in particular, between 2000 and 2019, we had 489,000 per year heat-related deaths. And they affected principally Asia and Europe. But now it comes to what can we do with this? And you can see here that only 54% of the countries are able to provide warnings for heat. Only half of the countries. And if we go more into detail and try to think whether you can provide a warning that is suitable to take a decision and in terms of health, so you were combining meteorology and health in a way that is suitable to take action, only 26 countries out of 193 have the capability to do so. So if we have to save lives, we need to do something with this. I spoke about lives, but we can also speak about economy. This figure shows last year that had a record $1 billion insured losses from extreme weather. So this curve also from 2000 to today shows that the economic impact of extreme events is also increasing, not only in the US, in the Americas, in Asia, Pacific, and Europe, Middle East, and Africa. So the impacts are also evident in the economy. What about the future? And you know that the IPCC, as I already mentioned to you, the Intergovernmental Panel on Climate Change, uses this kind of scenarios to show us what the world could look like 10, 50, and 100 years ahead. But they are projections. We don't know what will happen. And hopefully, we can make something to avoid the worst. But I will show you only one slide. Here is one of the scenarios presented by the IPCC. And you can see the colors there. So are the days per year where combined temperature and humidity conditions pose a risk of mortality to individuals. Numbers, days per year, see? So yellow to purple means that you can have more days where your population is exposed to death because of heat and humidity combined. That is the historical mean. You can also see that the less developed world is much more affected by this. But under different scenarios, the first one is what happens if the temperature anomaly goes to 1.7 to 2.3 degrees. The second shows what happens if we go above that. In the third one, what shows what happens if you go even above that. So what? These are scenarios. These are not. These are simulations done with models, with projections, where we take into consideration the greenhouse gases emissions, but also the economic growth, the population growth, and so on. But these are currently what we can speak about. So here comes what we can do: adaptation, mitigation, and I'm sure we can do more. And of course, I will bring the perspective of the organization I'm leading, but it's up to you. I will just show a couple of examples. There are so many, and you can think of so many. But this first one has to do with one fact. We have more extreme events. That's a fact. And because we have more extreme events, one adaptation strategy would be minimize the events, minimize the impact of these events, the losses. How we can do that? Well, if you have a hazard, it can be a flood, it can be heavy rain, it can be a hurricane, it can be whatever hazard you can imagine. But in order to protect people, you need first to know and understand the risk. It's not the same risk for everyone living in different places of the world. It's not the same. Then you need to anticipate that extreme weather. You need to monitor to see that that phenomena is going to happen, and then to forecast whether it will be worse, where it will move, what will happen with that phenomena. Then you need to provide access to the information. Makes no sense that I know I have a perfect forecast, but I cannot communicate that forecast. I need that to be very effective and oriented to different communities. And then, of course, you need to prepare and respond. So all of these are the pieces of an early warning system. It's a system because it has to do with many things that have to be interlinked and interconnected. This is a complex slide, but I would ask you to just concentrate on the first row to see at the global level which is the status of early warnings, early warning systems. And although this is a work in progress, the gray areas show that there are many things to assess. Again, we need a lot of efforts and scientists to assess what is happening globally. What we know in terms of impact, you can measure impact in terms of deaths, missing persons, or you can measure impact in terms of affected people. Numbers are different, but again, if you look down into the picture, you will see that the less developed world and the small island developing states, the bottom two, are those that are really more affected. In terms of the third column has to do with knowledge of risk. It's very variable across the world. The fourth column shows you the capabilities in terms of meteorology, monitoring, and forecasting the systems. The fifth row has to do with the possibility to communicate the early warning system. And the last two have to do with the capability to react and to recover from a hazard. So because of this situation, this very uneven situation across the world, is that we are engaged in this program, Early Warnings for All. It's an endeavor. It's that we work with different organizations, including Red Cross, International Telecommunication Union, and the Office for Disaster Risk Reduction, in order to address the 4 pillars that have been mentioned before: disaster risk knowledge, observations, monitoring, analyzing, and forecasting, warning, dissemination, and communication, and preparedness and response capabilities. In order to prepare all of these, you need to work, as I heard from one of the posters, you need to speak with people, they need to understand what the problems are. For example, you spoke about cookies. I would say, well, we should speak with every community to understand, to make them understand what their risks are. So that is a tailored approach to this problem. The good things about this is that early warning system save lives. And this figure shows you, in the upper panel, it starts in 1970, ends in our current days, and the bubbles show the economic losses associated with extreme events. And you can see that they are growing. So the economic losses associated with extreme events are growing. But when you go to the fatalities, the number of fatalities, same time, 1970s to today, you will see that the fatalities are diminishing. That's why, because we have early warnings. We can protect our society in a way. The second case I would like to make has to do with what about greenhouse gases, which are generated by fossil fuels and non-renewable energy consumption. What should we do with that? What are the adaptation and mitigation strategies? Okay, one mitigation strategy could be, of course, to transition from fossil fuels to renewables. That is, of course, an adaptation and mitigation strategy. And we also need an adaptation strategy. Why? Because also renewables are vulnerable to climate change. And I will show you in a moment. The good news about this, as it is with early warnings, I mentioned, early warnings save lives. So we have opportunities to adapt and save lives. In terms of energy, you can see here in gray the increase in non-renewables. And you can see from 2002 and 2022, there is no increase in non-renewables. On the other hand, we have a clear increase in renewables. So we have expectations. And the renewable share, so the part of the market that is shared, is taken by the renewables, is increasing. So these are good news. The other good news is that renewables are an opportunity for the less developed world. For example, Africa has a huge opportunity to really have lots of possibilities to exploit renewables in terms of solar, in terms of wind energy, and also in terms of hydro. It's about investment. Only 2% of global investments in renewable energy in the last 20 years went to Africa. I mentioned the issue of assessing, in a way, the vulnerability of renewables. And this is just an example for you where the vulnerability is and why we need information to assess that vulnerability. On the upper left, you have a nuclear plant near the coast. What happens if the sea level rises? The second picture shows you a cold air outbreak, very cold temperatures. So what happened? The energy demand for minus 40 degrees in Alberta was really demanding and challenging. On the opposite side, a very warm event in my country, near 43 degrees, also challenged our energy system. In fact, we couldn't cope with that. And then you have, for example, over there in the top, the freezing rain that has coated power lines in thick ice across over vast area in Russia. So the system can be completely damaged because of this phenomenon. And fires in Australia have destroyed the energy system. So the renewable energy is also vulnerable to climate change. So we have to adapt to these new conditions and be prepared for that. The message, as the renewable energy expands, its reliance on weather and climate conditions also increases, and we have to produce more tailored weather and climate and water services to cope with all the variability that this system has. Okay, my closing remarks. We went from climate change. Weather speaks, because every day we feel something different and we can feel that. And society reacts. You will tell me how much you think that society reacts. Climate action. I know you have a focus on sustainable development goals. Climate action is one of the sustainable development goals. Everyone can do something in terms of climate action. But I hope that with this very brief presentation, you have also an idea that climate does not only speak about the sustainable development goal, climate action. Climate and weather impact hunger, impact water, impact health, impact energy, and impact urban life, impacts almost everything. Adaptation and mitigation are in our hands. We all have something to do about it. And I would like you to consider what you are able to do. I also would like to highlight that we have common but differentiated responsibilities and respective capabilities principle. This principle applies to states, to the countries, but it also applies to individuals. We have common but differentiated responsibilities, because it's not the same for someone that lives in the developed world, that someone that lives in the developing world, that someone that lives in a small island state, or someone that lives in a less developed world. And my last message is that you, scientists, you, new generation, for sure, will have the opportunity to contribute to adaptation and mitigation using your mind and your behavior. Thank you very much for your time.
Thank you very much, Professor Celeste Saulo. So I guess that you students have lots of questions to ask to Professeur Celeste Saulo. Il y a des micros qui circulent dans la salle. N'hésitez pas, vous pouvez poser vos questions en français ou en anglais. Elles seront traduites si c'est en français. Vous faites un signe. Allez-y. Je ne vois pas de bras levés.
Je peux poser ma question en français, ça ne dérange pas?
Oui, oui, bien sûr.
Vous nous avez présenté de différents scénarios, et notamment on en a vu un qui promettait que ça allait redescendre à plus 1 degré. Est-ce que vous pensez vraiment que ce scénario est possible?
So you talked about a scenario of plus 1 degree, and do you really think that this scenario is possible, can happen?
With 1 point.
1 point.
No, but I didn't listen there. The temperature he mentioned.
Yes, 1 degree more.
Yeah. I think that the IPCC tells us that it's likely that we may have this scenario. between 2050, around 2050. Of course, there is a lot of uncertainty, but when you read these reports, you can see that within the uncertainty, they mention that, of course, this can be the case, and that's why we should be prepared, and we should avoid that, I would say. You mentioned 1 degree more. I imagine that you are mentioning 1.5 or plus 1 or 2 degrees or something like that. And it's likely. That is what the IPCC says, unfortunately.
Yes, there are questions over there in the back.
Do you think that real climate action can be taken without a real political will at the same time?
I cannot hear.
So could you please repeat louder?
Yes, louder, please.
Do you think real climate action can be taken without a strong political will being there at the same time?
Yeah, definitely. Yes, I think that I tried to show a couple of examples, but you had a poster today. Unfortunately, I couldn't understand because it was in French, the explanation. But engaging with climate action, with every behavior, everything you do can make a difference. So definitely climate action can be, should be fostered to really improve the situation and avoid reaching 2 degrees anomaly that we would like to avoid. Not only because of that for us, but particular because of the ecosystems that will be hardly damaged.
Hello. Do you think that fight against climate change and economic growth can be compatible?
That's an interesting question. And that is something that is discussed during the conference of the parties. And we think that I mentioned this issue of common, but different responsibilities in terms of economic growth. Definitely, economic growth has to be changed. But you know that this model where economic growth was like the example of the well-being of the society was the economic growth. And we have to reconsider that kind of approach. We have to think of development more than economic growth, development, and take into consideration that this development needs to be sustainable. And we also need to take into consideration that we have millions of people that do not have access to water, do not have access to energy, do not have access to food. So when we speak about economic growth, I would say we should speak about also how to share that economic growth in a way that is, I would say, of course, more equity. We need more equity in terms of growth, but also, of course, growing in an intelligent way that we do not use the planet for increasing our economic power, you know.
Hello. It seems to me that the awareness in developed countries about the facts of climate change is very high. However, there is no strong political will in most of these developed countries to fight climate change and to take strong actions. What do you think that is? Thank you.
Well, you know that it's interesting because I showed you, for example, the energy, and we are changing to renewables, and this is working well. But the point is that it is not enough, and because we can see that greenhouse gases are increasing. It's hard for me to answer what is happening with the developed world, that we cannot cope with what we have created in terms of the quality of the atmosphere and the oceans. So I think I don't have an answer to that question. I think that we should be more aggressive in terms of I mean the developed world. Now I'm living in the developing world, but coming from the developing world. And I think that in the developing world also we need to be more aggressive. But we need to change our minds completely. We are arguing for little bites, and we are not solving the main issue, not yet.
Hello, thank you for being here. I'm there. Oh, okay. So I had a question about the carbon team, because there's a team in EPFL that's trying to get the CO2 from the atmosphere and try to do something else with it. So I was thinking, is it, or these types of projects, are they taken seriously in terms of how it can have an impact on the environment later?
Could you raise your hand and repeat the question so I can see you better and I can understand you better?
Celeste, she's in the middle in the back. No, everybody's waving, it's not just one. Yeah.
Could you repeat the last part of the question, please?
So just about the carbon team, just trying to get the CO2 from the atmosphere, can it seriously change the environment or what's happening right now? Or when the technology will be efficient, will it be too late?
You mean about capturing the...
Yeah.
Well, that is a very interesting topic. This being discussed, how to remove carbon dioxide and other gases from the atmosphere. By this moment, we all think that we have to be creative, and science is trying to help in finding creative ways of capturing CO2. But up to now, the natural systems, I would say, the forests and the oceans are the most effective ones. Still, we cannot replace everything on Earth with forests. So we have to think about something. And that's why we think that carbon removal mechanisms are important, but are not enough. And that's why we put a lot of emphasis in avoiding putting more carbon dioxide into the atmosphere, because our capability to remove it is very weak compared with the huge increase that we have generated. So it's a strategy, but it's not to rely. And also, I would like to mention something else. If you remove carbon, but you continue putting carbon dioxide, the ecosystems will also be damaged. And that is not what we would like to see.
Thank you.
What exactly is the power of the World Meteorological Organization? Can you do projects without the country's agreement, or how much margin do you have to intervene?
Well, we have the power of science. We have your power. So what we bring as an organization is that we try to gather all the data, all the evidences, robust information. We are not arguing and putting opinions into the system. We are putting the best of our knowledge, and we are gathering information from all over the world. That's the power of the organization, science and collaboration. And also, the other power of the organization is trying to bridge between the developed world and the less developed world, trying to close the gap in a way that we can help the less developed world to have their own systems to prepare, to have their own capabilities, to develop their capabilities. But we are not the ones that decide how policies should be made. What we put in the system is the information, and we really try to contribute to make better decisions. That's our power.
Hello. Okay.
Where are
So
you? Over there.
I hope I don't make any mistake, but I heard that you were the first woman to get to this position.
Could you speak it louder, please?
Can you hear me now?
Yeah.
Okay, nice.
Thank you.
So I hope I don't make any mistake, but I heard that you were the first woman to get to this position. So I was wondering what were the challenges you had to face and what inspired you to start this journey?
Okay. Well, challenges. Since I was your age, I had challenges, and I'm sure that you also have challenges, different types of challenges. Starting from the fact that sciences, when I was young, as you are now, were not the choice for, or the most frequent choice for women. But my family supported me. Then, when I worked at the university, it was hard for me to progress in my career. Males were always chosen before women. And the other challenge was combining family and my work, you know. I have two sons, a son and a daughter, and there was a time in my life where my possibilities were very restricted. I had to raise my family, but in the end, it worked. It worked because I like it, because my family supported me, and it's a time of your life where if you choose to have a family, regardless of where, when, you will have to dedicate to your kids. But then life continues, and then if you love what you do, you find a way to do what you want. And you also had challenges in Argentina to become the director of the Met Service, but not because I wanted to be the director of the Met Service. It's because they came to look and say, okay, would you like to be the director of the Met Service? I was in the university teaching with my students, with my group of research. I was so comfortable with my papers and everything. And I was criticizing my Met Service in a way. And when they asked me to be the director, I said, okay, I am criticizing something from the outside. Why not try to do something from the inside? That was a challenge, leaving the university, this kind of life where you decide what you do, you discuss everything, no? And then you go into a managerial kind of responsibility and tension and so on. That was a challenge. And I'm very happy that I accepted that challenge. And then the challenge of the WMO. The WMO has a very, it's because it has a power, as you asked before, but in terms of male and female, the numbers of directors of Met Services, we were less than, I would say, 17%. So we were very few. But it was like natural. I liked the WMO. I was interested in using my experience from my country to bring it to the organization, just to bridge different cultures from what I learned in my country and what I could give to the organization. And I had a lot of support now. I'm very comfortable in the WMO. I know I have challenges, but we all face challenges. And I'm certain that when you do something that you love with passion, you will receive the support you need, and you can make a difference. And I think that this world needs us to make a difference. And that's why I think that for you, that's the message. For the younger generations, regardless of male and women, I would say that go for your challenges, go for your passion, and do your job. Do your job, and you will change the world.
I've got another question. I'm sorry here. I got a question about cloud seeding. That's where you like seed clouds to decrease the sun rays going to Earth and then increase the reflection. What do you think about this? Does this really work, or is it just nice and destroys actually the ecosystem?
Well, there are very brilliant scientists analyzing this process of cloud seeding, and I would say that cloud seeding is used in many ways to enhance precipitation also, to avoid hail, and now it's trying to change the way in which the radiation reaches the surface so that they are more, we can reflect more energy on the top of the clouds and see what happens. And that is what we call solar radiation modification. I'm not the one to tell you whether this works or not. I think that we have to discuss it in a very big forum of scientists, because it will bring impacts. And we don't know what the impacts are. It's not that you are playing in your lab. If you change the solar budget, you don't know what will happen to you. And you don't know what will happen in Australia. And you don't know what will happen in Antarctica. You really don't know. So when we think about these creative solutions, I think that we have to, yes, work in depth, try to understand them, but also share this vision with all the scientists of the world, because that will make a change. And maybe it will not be a change for the better. We don't know. But we are concerned about solar radiation modification. And it's not about only a physical principle. It's about an impact that we may not be able to control.
Okay, so with the pandemic and all came the lockdown. I was asking myself if it has a significant impact on the global climate, and if it could be considered a solution for the climate problem.
Could you, the last part of the question, could you speak louder, please?
Sorry. So, is confining, locking everyone indoor, I know it's not the solution, but could it help the climate going better, slowing down the world?
Not sure if I get the question right.
During the pandemic, we had to stay at home with the climate.
Oh.
And actually did have an effect on the global
Well,
climate. And
during
would it
COVID,
be a solution to just go
yes,
back home?
I think I got the question, but I'm not quite sure. I don't think, yes, we have to change our habits, for sure. I don't think that staying at home is necessarily a good idea because of many other things. The group that showed the bicycles in Amsterdam, it's about our health and many other issues that we have to take into consideration. During COVID, there was a very small, I would say, decrease of CO2 because we were at home. We were not traveling, we were not flying, we are not consuming that much. But it was very, very marginal. It was very weak. So if you stay at home, you may save something, but still, when you have to manufacture many other things that you use to stay at home, you will be also creating lots of CO2. So we have to change our behavior, yes. We have to consume less, yes. But probably staying at home will not be that solution. As I think so, at least.
Okay, we still have time for 2 more questions, maybe?
You mentioned the fact that investments for renewable energies in developing countries is relatively low. Do you think that's because the investors are reluctant to develop those energies, or the developing countries are reluctant to go into those energies because they're less efficient than fossil fuels?
Nice and difficult question, as all the questions that you've been doing. Thank you so much. Honestly, I should be part of the table that discusses this, but I don't know the details. I can imagine that it's a mix of many things. The transition to renewables costs money. And when you don't have the money, you cannot transition to any green energy unless someone puts the money. And the issue of how you handle your sovereignty and whether those countries putting the money do not make the decisions in terms of your evolution or your development is something that is always an issue of concern. So what happens in the developing world? Sometimes it's very hard to transition to clean energy because fuels are cheaper, and all the system has to be renewed to be able to cope with renewables, particularly solar and wind. So as I would say, as a global community, we should put the money to help the less developed world transition towards green energy. They will not be able to do it alone. And this is not a problem about money, honestly. I think the money is there. It's about economic power. And that is something that has to be solved by those that handle that power. It's not me. Definitely it's not me.
Yes. Où sont les micros? Over there.
Comment on peut convaincre notre entourage de changer de comportement quand on sait qu'il y a des études qui montrent qu'on a atteint une espèce de point de non-retour et que quoi qu'on fasse, c'est foutu entre guillemets. Comment on peut convaincre les gens de changer de comportement?
So how can we convince people around us that we need to change?
Well, this is a way to convince people. And you are the network to convince others. There is no other way than speaking and explaining and working and showing that this is possible. So it's up to us. We are all responsible. You are younger, much younger than me, but I will never stop trying to convince people of changing. And I hope that you will never stop. It's part of our job to keep this planet clean. And we cannot be, cannot just give up. We have to work as a network. As the WMO, we have a power because we have a voice, although my voice is not helping today, but we have a voice. But everyone has a voice, and particularly the new generations and the institutions should engage to convince that we should go in a different direction.
I think there was a second part in the question, if I heard well, that was that nothing could be done. So
no.
I think that's what you meant too, that there was no solution at all, and whatever we would do, it will be not
definitely.
enough.
I think yes. No, please, I hope that you don't get the idea that there is no solution. I think that the idea is to understand that we are under a big risk, and the only way to avoid this risk is engaging. Engaging as scientists, engaging as individuals, engaging as society, engaging in every role you can engage. Definitely there are possibilities. Changing fuels to green energy is possible. Saving lives is possible. Helping the less developed world is possible. It's about whether you take the responsibility of doing that or not. And that is part of the challenge, for sure.
Okay, thank you. Maybe one last question?
Yes, I have one.
Can you see him?
Could you stand up? Or oh, sorry, yeah, over there.
Over there.
No?
Yeah, I was thinking about.
Yeah. Yeah.
No,
Okay.
Yes.
Do you think that the economic pressure of governments over some, I don't know, I can think, for example, of malus écologique in France. Do you think that economic pressure is a solution or an efficient solution to reduce gas emission?
I think that yes, I think yes. Many people speak about this economic, so changing, for example, changing the prices as in a way that, if I get the question right, it should be more expensive, for example, to buy fossil fuel, than to use an electric car. So putting economic pressure into something that is not green could help. That certainly would help. But I read in some paper, I don't remember which paper, that everyone was speaking about climate change and they were worried about climate change and so on. And someone asked this, did a survey and asked, okay, but if you should spend 10% more a month to cope with climate change, would you be able to do so? And the answer was no. The answer was no. And that's why I'm talking to you, because the answer should be yes. If I have the money, yes. And in general, we are not aware that 10% is not that much if you are to save the world with that. So economic pressure, you mean about what we mean about economic pressure? I'm not sure. But if we think individually, we will never make it. We will make it if we think as a community. And when we have to spend 10% more is to avoid something worse to happen, we should consider that very seriously. It's not 10% to my pocket. It's not meaningful when we speak about the planet.
Thank you. Thank you very
so
much, Professor Celeste Saulo. Thank you. Thank you. Et merci beaucoup à vous toutes et tous. Bravo à Com Gaillard aussi, le gagnant du concours d'éloquence, qui a présenté votre parcours, Celeste Saulo, ainsi qu'aux étudiantes et aux étudiants de 2023 qui nous ont présenté leur poster. Merci évidemment à toute l'équipe qui a rendu cet événement possible, ainsi qu'au professeur Yann Estaven, professeur Rudolf Marer, et bravo à Jean-François Baird. Merci beaucoup, bonne soirée, bonne suite.